Yes, so good morning everyone. In the previous lecture, we have seen the introduction to Cartesian system, and we also saw at the end of the lecture the transformation of coordinates, which involves scaling and translation, right? In this class, we will study the concept of slope and various forms of equation of a straight line. So what is the slope? So let us take a very simple example here. Suppose there are two hikers who are hiking from this point, these 2 points, point A and point B, and they are reaching at the same height. Okay, this height is the same. So let's say this is point C. Now, from here to here and from here to here, as you can see, the distance covered are different, right? But at the same time, what is the vertical distance and what is the horizontal distance? So what I mean by that is, okay, let me just draw a separate diagram here. Suppose this is first one and this is the second one, okay, from A to C and B to D. So it is very clear which segment has a greater slope. So all of us know slope is a measure of steepness. Slope is a measure of steepness, right? How difficult it is or how easy it is to climb up. So you can see this segment AC has a gentler slope, whereas BD has a greater slope, right? Now, how do you determine the slope? How do you measure it? So it is very simple. You're at A, right? And whatever is the distance, horizontal distance, let us say it is 0 right now, and this height is say 40, and here you are at say time t1 and here you are at time t2. Similarly, this is 0 comma t3 and this is again 40 comma t4. Then what is happening is you are covering the distance of vertical distance of 40, right? Oh, I'm sorry, this is x and y coordinate I have interchanged. It should have been t2 and 40 and this should have been t1 and 0. Similarly, this should have been t3 and 0 and this should have been t4 and 40. Okay, so the vertical distance covered in both the cases is 40. This height is 40. But what is the time taken? So here you see the time taken is t2 minus t1. So that is the slope. You can say it is rise is to run. So it is 40 meters you have risen above divided by t2 minus t1 for the first one. In the second case, it is again you are covering a distance of 40, but the time taken is t4 minus t3, right? Now, as you can see, t4 minus t3 is smaller, so this number is going to be greater than 40 upon t2 minus t, right? So, if you cover the same height, but in a shorter span of time, then then the slope will be higher. Whereas if you cover the same distance in a greater amount of time, then the slope will be smaller because this is lesser steep as compared to this one, right? I hope all of you agree with this. Now, having understood that slope is a measure of steepness, let us look at two standard results associated with the slope. So the first one is where you have two parallel lines. So when we say the lines are parallel, when they do not intersect, isn't it? So if you say two lines are parallel, then obviously they have the same slope. So slope is usually denoted by the letter m. So if this one is having slope m1, this one is having slope m2, then same slope means m1 is equal to m2. So this is the condition for parallel lines. Okay, very simple proof, visual proof you can say. Now, the next important result is where the lines are perpendicular. So all of you look at the board here. Last time we have seen coordinates and we will see the application of coordinate system here. So they say two lines are perpendicular if and only if the product of their slopes is equal to -1. And very easy it is to prove. So let us see how. Suppose there are two lines which are perpendicular. Then using shifting of origin and suitable scaling, what I can assume is the two lines which are perpendicular are actually intersecting each other at origin, right? We can shift the origin suitably. Suppose this is line L1 having slope M1, and this is line L2 having slope M2. Okay, let me denote L1 here and L2 here, and this is the origin at which they are intersecting. What I want to prove is M1 into M2 is equal to -1. So pick any point here and pick any point here. Okay, what you can do is you can drop a perpendicular from this point on the x-axis, and the same thing you can do here, right? Okay, let this point have the coordinates a comma b. Let this point have the coordinates p comma q. Now, using basic definition of coordinates, you know that this distance is b because this is y coordinate, this is a because this is x coordinate. Similarly, now please note we are in the second quadrant, so let's be careful. Now q is definitely positive, but distance p here, okay, I'll just call this as mod p because this is distance p, okay? Nothing specific here, but I'm calling it as mod p because this is distance. Now, the next important observation we can make is because I have dropped these two perpendiculars, this is 90, this is 90, right? Now, if this angle is theta, then what happens to this angle, one of these angles? So it is very easy. Please note these two lines are perpendicular. So if this is theta, this is 90, then this has to be 90 minus theta. Similarly, if this is 90, this is theta, then this has to be 90 minus theta, and this has to be theta. So can you observe, if I name these coordinates as O, then A, B, and this is O, this is P, and this is Q, suppose capital P, capital Q, then we can observe that triangle OAB is similar to triangle. Now this is 90 minus theta, and this was also 90 minus theta. So here point A will correspond to point O. Then this is 90, which is B, this is 90, which is Q, and this is P, right? So OAB is similar to POQ. Then what you have is OA is to PO is equal to AB is to OQ is equal to OB is to PQ, right? Now, what is OA? So if you look at this OA, or let's forget what is OA, it's not required, leave it. Now, what is AB? So AB, if you look at it, is A is to, what is OQ? OQ is mod P, as we said, is equal to OB. What is OB? OB is, what is OB? OB is, AB is B, okay, sorry. This is B, OB is A, and divided by PQ. PQ is Q. Now what we want to prove is product of slopes. But what is the slope of OA? So you see slope of OA is equal to y2 minus y1, right? Difference between the heights. It is simply B upon A. So if you bring A here, you will get B upon A is equal to mod P upon Q. And what is slope of OP here? So slope of OP is equal to, now this time it is going to be Q by P, right? So now what you can observe is B upon A is equal to mod P upon Q. So if you cross multiply, then you can observe, I'll write here because there is some insufficient space. So we'll get B upon A into, this is Q upon mod P is equal to 1. Now we are just one step away from the actual result. What is mod P? Because you see we are in the second quadrant, P is negative. So mod P will be minus P. So you will get, this is same as B upon A into Q upon minus P is equal to 1. I believe you understood that this actually proves that M1 into M2 is equal to -1 because that is precisely the slope, right? This is M1 and this is M2. Am I right? Okay. Now, let us look at the, so if you want, you can take the screenshot of this proof here. Yes, if you have any doubt, feel free to ask. Okay. Now let us go to the next one where we will define uh, the intercept, because they are all required in problem solving further. So what is an intercept? So intercept is the point where line intersects the coordinate axis. So look at this. Yeah, we have this line here. This is the XY plane. And we have this line which is intersecting the x-axis at point A, having coordinates a comma 0, and y-axis at B having coordinates 0 comma B. So this A is known as the x-intercept, and this is known as the y-intercept. Okay, so as you can see, the value of intercept can be negative or positive depending on which side of the axis it is, because we are talking about the positive x-axis here. This could be 7, 5, but you can also have a line like this, in which case this is -5 comma 0 and this is 0 comma 4. So for this line, the x-intercept is -5 and the y-intercept is 4. Okay, very simple. Okay, now let us look at various forms of equations of a straight line. So what is the first equation of a straight line? So the first equation of a straight line is given by slope-intercept form. So in slope-intercept form, they write it as y equal to mx plus c, where what is m? M is the slope. What is c? C is the y-intercept. Now just now we noted what the intercept is, right? So three things you should note here. First, in the slope-intercept form, y has to be on one side, m has to be the coefficient of x, and c should be isolated. Okay, so this is the slope-intercept form. Next, we have, the name itself tells you, it is known as the double intercept form. Now what happens in double intercept form is, they say, like the name itself tells you, right, double intercept. So you have to focus on both these intercepts. So we will write the form as x over a plus y over b is equal to 1. Where what is a? See, because a is below variable x, a is the x-intercept. Because b is below variable y, it is the y-intercept. So once again, which three things you should remember to write the double intercept form? First thing is, right hand side has to be 1. Second thing is, below x there has to be the x-intercept. Below y there has to be the y-intercept. So for example, if you go back to one of the lines we discussed, or take a different line, suppose this line, suppose this is 0 comma -2 and this is -4 comma 0, then the x-intercept is -4, y-intercept is -2. So this, if you want me to write the equation of this line in the double intercept form, it will look like x upon -4 plus y upon -2 is equal to 1. Is equal to 1. Okay, I believe all of you understood this double intercept form. Then the next is slope point form. I hope you have taken this down or taken a screenshot. Okay, now the next one is slope point form. So in case of a slope point form, they write it as y minus y1 is equal to m into x minus x1. So where, what is m again? M is the slope. And what is x1, y1? x1, y1 is a point, or is a known point on this line. Okay, is a known point on this line. So you can also say x1, y1 is a point through which the line is passing. Then the next one is 2-point form. So basically, 2-point form is just, you can say, special case of slope point form, because they replace m by its formula, right? We have seen the formula for slope was y2 minus y1 upon x2 minus x1. So they just substitute for m there. So you will get y minus y1 is equal to y2 minus y1 is to x2 minus x1 times x minus x1. Where what are x1 and y1? So we can say x1 and y1 are x1 y1 and x2 y2 are 2 points on that line. Specific 2 points on that line. Okay. Now, just a simple question from my side. In all 4 equations we saw, we gave an explanation for m, x1, y1, x2, y2, etc. But what are x and y? The basic variables which we have used everywhere, x and y. What do x and y stand for? So x comma y indicates an unknown point on the line, a variable point on the line. Okay. This is an unknown point on the line. I believe all of you are understanding this. Yes, please take a screenshot if you want. Okay, now the last form of equation of a line that we will see here is known as parametric form. Okay, what is it called as? Parametric form. So let us see how to write the equation of parametric form here. Now, to understand the parametric form, let us look at the line here. Take any line and suppose it is making an angle theta with the x-axis. Okay, this theta is known as an inclination. And there is one more method of finding the slope of the line, which is tan theta. But can this theta be anything? No, it has to be measured in the anti-clockwise direction, okay, away from the x-axis, like this. So I'll write here if you want, anti-clockwise direction. Okay, then tan theta is supposed to be the slope of a line. Now, what they say is the parametric form of equation of a straight line is given by, choose any point on this line, say x1 comma y1. Then the equation of a line is given by x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to r. Now what is this r? This r is precisely the parameter. It is the distance. Okay, distance from where? So I'll write here distance from x1 comma y1. And once again, what is x1 comma y1? x1 comma y1 is a known point. Okay, now just to make things clear, let us just look at this line, same line, but I've just drawn it this way to make you understand easily. Suppose this is the fixed point x1, y1. Okay, then there are how many points on this line which are at a distance of r units? So you can see there is one point here which is r units away, and there is another point here which is also r units away, right? So there are always 2 points which are, let's name them as A and B, and suppose this known point is P. So there are always 2 points for a fixed r away from P. So this happens because sine theta and cos theta can give you 2 values depending on what theta is. Theta can be acute, theta can be obtuse. Okay. So in particular, if you want, I can simplify this further and write that every point on this line can be written as r cos theta plus x1 comma r sin theta plus y1. Okay, this is how you can write every point on this line using the parametric form. Typically, you must have noted this is useful when you want to find the points on a particular line which are at a fixed distance from a fixed point. Okay, so please note this down. Or take a screenshot as you like. Okay. So this is the parametric form. So there is one more form of equation of a straight line, but we will not look at it right now. For the today's lecture, this much theory is enough. Now let us look at some problems. Now when we solve problems, let me tell you that sometimes we can use what we have done in high school geometry. We can apply what we have done in high school geometry. So for example, let us look at this problem here. There is this simple question. Okay. Now you may say that this concept is not taught today. Yes, the concept is actually covered in high school, but not taught here. But still, we can solve this problem. So let us say that there is a triangle formed by points a1 comma 0, b4 comma 0, and c0 comma root 15. Okay, these are the 3 points. Then they say angle bisector from A intersects BC at D. Okay, then the question is find the ratio BD is to DC. Now this is quite a simple question. Why? Because you see, if you plot these points here, somewhere here is A. I'm not saying this is accurate figure, but still quite close one. And this is where somewhere C is, which is 0 comma root 15. So this type of triangle we may get. Now what are they saying? The angle bisector from A, here is the angle A, angle bisector from A is intersecting BC at D, right? You want to find what is BD is to DC. Now this is actually a question from high school geometry. You must have proved in class 9 or class 10 that if AD is the angle bisector, then it divides this segment in the ratio AB is to AC. So what you want to find is BD is to DC. But don't you agree BD is to DC is same as AB is to AC, right? This is what you want to find. Now, can't we find AB and AC simply using the distance formula, right? So let us find out what is distance AB. Now, since we are on x-axis, you see the y-coordinate is 0. So we are on x-axis, so the distance AB is simply difference between the x-coordinates with the modulus, but here both are positive, so the answer is 3. And what is AC? So AC, if you apply the distance formula, it is root of 1 minus 0 the whole square plus 0 minus root 15 the whole square. So this gives you 15 plus 1, which is 16. Square root of 16 is 4, which means AB is to AC is 3 is to 4. And that is same as BD is to DC. Okay, that is same as BD is to DC. So you see what we did, we used 2 things. First, the concept from high school geometry, we know this result. And second, we used the basic distance formula, which we have studied in the previous class, right? We just applied the distance formula here. I'll show you another question, which requires, as I said, the application from maybe high school geometry class 7 or class 8. Okay, I believe you have finished writing this or take a screenshot. Okay. Now, the next one is here. Just give me a moment. Yeah. There are 2 points, A minus 3, 2, and second point is B 2 comma 5. Okay, there is point P 0 comma K on the y-axis. Okay, now such that when I have said there are these 2 points and P on y-axis, such that mod of PA minus PB is the greatest. Then the question is, what is K minus 1 upon 5? Okay, what is K minus 1 upon 5? So this you can say is a numeric entry type or integer type of a question. Let us see what the answer is and how to solve it. So I told you this is actually the question based on high school geometry concept. Let us see how. So can you observe these are 3 points and clearly they are non-collinear, right? So they will definitely form a triangle. And what do you want? You want mod of PA minus PB to be the greatest. So if PAB is a triangle, I can write in triangle PAB, what we studied in high school, that addition of any 2 sides is strictly greater than the third side. So PA is the third side, which is less than PB plus AB. We have studied this in high school, right? So if you take PB to that side, and we also know that PB is less than PA plus AB. Right? This is what we have studied in high school. So if you take PB to this side and PA to this side in equations 1 and 2, you will get PA minus PB is less than AB and PB minus PA is also less than AB. Combining these two, we can say mod of PA minus PB is less than AB. Am I right? Because see, this is original quantity, suppose C, small c, then this is minus of C. So C and minus of C are both less than common quantity, so mod of C is also less than that common quantity. Now, we are in a triangle, so there is this strict inequality. But here they are not saying that like we have to deal with the triangle. They are only saying that this should be the greatest. Now, can you see this value, this quantity will be the greatest if there is an equality sign here. But we know this in this triangle inequality, the equality will hold only when PAB are collinear. So if you give me, I believe you have noted these down. So if you allow me to draw the picture, it will look something like this. Look at the board. Point A is minus 3 comma 2. Point B is 2 comma 5. It is here, right? So this is B, this is A. Point P is somewhere on the y-axis. So let me say point P is here. Such that what they say PA minus PB, mod of PA minus PB is the greatest. And just now from this we have concluded that this will be greatest if it is equal to, that means P, A and B are collinear. Now right now you can see that they are not collinear, right? Say let's not worry about these numbers here. But what I can do is I can take the reflection of A about the y-axis. So it will lie somewhere here, right? The reflection will lie somewhere here. Then can you see this PA and say the reflection of A is A dash are collinear? So if moment they are collinear, this property will be satisfied, right? Mod of PA minus PB will be equal to AB. So what I need to do is I will find the reflection of A. Now what was A? A was minus 3, 2. I'm finding the reflection of A about the y-axis. So where it goes, so you see when I take the reflection, this remains the same. Height is 2, but the x coordinate changes from minus 3 to plus 3. Now as you can see, this is 2 comma 5. Now as you can see, P, A dash and B are collinear. So this line, if you want to find P, it is precisely the intersection of line A dash B with the y-axis, right? I believe all of you understood this and you have finished writing this part. So what happens here is, you have, yes. So now what is the equation of AB or A dash B rather? So can you observe I can use 2.4. So it is y minus, let us say this is x1 y1 and this is x2 y2. So we have y minus y1 upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. So on simplifying, we will get y minus 5 upon minus 3 is equal to x minus 2 because this is 1. So as I cross multiply, we will get y minus 5 is equal to minus 3x plus 6. Now, beyond this, I may not simplify because what I am interested in is the value of k, which means I want to find where this line is intersecting the y-axis. So simply we will put x equal to 0. You see that is what is indicated here. I should put x equal to 0. So if you put x equal to 0, you will get y minus 5 is 6. So you will get y is equal to 11. So if y is 11, that means that y coordinate or rather value of k is 11. But the original question was find the value of k minus 1 by 5. So here k is 11, so it is 11 minus 1 by 5, which is 10 by 5, which is 2. So the final answer is 2. I believe all of you understood this and how we applied the basic high school geometry to find the maximum value, the greatest value of mod of PA minus PB. Okay. I believe all of you understood why I took the reflection, because originally we were given this triangle P, A and B. But as I take the reflection, I believe you understand that this distance is same as this distance, but now I am applying the collinearity trick here. Right? Okay. One more question and we can stop today. So I believe you have finished writing or taking a screenshot.